Hello, geometry. All right, today we're going to start chapter 8, similarity. All right, this chapter is going to work with similar figures. All right, but in order to learn about similar figures, we need to backtrack a little bit and review some algebra concepts that are very important for this geometry concept. So today what we're going to be doing is we're going to talk about ratios and proportions. So, first of all, what is a ratio? A ratio is actually a comparison of two different things, and you can write them in a couple different ways. You can write them as A to B, A colon B, or A over B. All right, so what this is telling us is that, for example, if I'm comparing two things like how many boys to girls there are in the class, and I want to say there are 10 boys to 7 girls. All right, that would be a ratio. All right. So also we have something called proportions. Proportions are two ratios that are equal to each other. Okay. So first of all, we actually have some relationships between the A and the D and the B and the C here. All right. And those actually have names. The A and the D are called extremes, and the C and the B are called means. All right, so what this is telling us is that we can actually do some things with this A and this D and this B and the C. So if I want to find out if these two ratios are proportional, I can actually multiply A times D and B times C, and if they are equal to each other, then they are proportional. Yay! All right. So, I think we understand what ratios and proportions are. But did you know that fish have a memory span of 3 seconds? I think middle schoolers do too. I can still remember cross multiplication. What do you think? Do you think you can still remember cross multiplication? Let's see if you can remember. Solve for x. How on earth am I going to solve for x? All right, same sort of concept. If this is a proportion, and these two, the extremes and the means, should be equal to each other, then we can probably set up a proportion. All right, so what I can do here is I can actually say, well, 9 times x, or 9x, is equal to 18 times 4. All right, and then we're just going to multiply over here, so we're going to keep our 9x, bringing you back to algebra. 9x equals 18 times 4 is 72. Divide both sides by 9, and x is going to equal 8. All right, so please do these three problems on your own tonight. Remember, same sort of idea. Even when we have this x plus 3 here, remember when you're cross multiplying these to use the distributive property. So here, I'll just give you a hint. You're going to have a problem that looks like, the beginning of your problem on this one is going to look like this. All right. Okay. Now, we can also use this when we are talking about word problems, okay? Now we have find the length of the model to the nearest tenth of a centimeter. So we have a real car and we have the model of the car. And we want to find the length. We know the width of the cars. So we can actually set up a proportion. All right. So in this case, we're going to say 1.8. Oops, before we even do that though, my mistake, we need to make sure that um, our units are in the same measurement. In this case, I have meters and centimeters. All right, so I need to convert these to centimeters. So 1.8 in meters as centimeters is 180 centimeters and 500 centimeters. There we go, that makes more sense. All right, so now we're going to set up our proportion. Sorry about that. So we're going to have 180 over, comparing it to the other length, 6.3 equals 500 over x. Now, if you guys notice, I kept my actual car on top and my model on bottom, and I kept my widths compared and my lengths compared, okay? So then from here, I can just cross multiply, so I have 180x equals 500 times 6.3, which equals 3,150. Divide both sides by 180, and my x, or in this case my length, is going to be 17.5 centimeters. All right, so that's all I have for you today, guys. Make sure that you come in with any questions. This should be a really good review for you of an algebra concept, really a pre-algebra concept. And just make sure that you have a good grasp on this before we start jumping into some of the more complicated geometry stuff, okay? All right, thanks, guys.